So imagine needing your dual monitors, touch screens, and your entire audio setup literally a quarter mile away from your computer tower, and you need absolute zero lag.
Yeah, I mean, standard copper cables are going to degrade and just completely drop that signal before you even reach the parking lot.
Right. Today, we're doing a deep dive into the exact hardware that solves this. It's the Smart-AVI SFXPRO-2P-M-S fiber extender. We really want to figure out why bridging this kind of physical gap requires such, hardcore industrial
And
engineering.
how it actually pulls it off. Because to span that 1,500 feet, or about 457 meters, this device relies on something called duplex multimode fiber.
Okay, duplex multimode fiber.
Right, and it carries dual DVI-D video, meaning you get crisp 1920 by 1200 resolution at 60 hertz. Plus, it handles USB 2.0, 1.1 stereo audio, and RS-232.
Wait, RS-232, isn't that an older serial data standard?
It is, yeah, but it's a rock-solid standard used heavily for heavy machinery controls.
Got it. So let's translate some of that for you listening. Duplex basically just means two fibers. So one for sending data, one for receiving, kind of like a two-lane highway.
Exactly, and multimode means the physical cable is thick enough to basically bounce multiple light beams down the line simultaneously.
So it's like an incredibly long, flawless umbilical cord for your tech. But it's not just a dumb pipe, right? It's like an instantaneous translator.
That is the core of it, yeah. You plug your standard USB and video cables right into the transmitter. The box takes those electrical impulses, translates them into pulses of light, and shoots them down that fiber highway
And then the receiver at the other end just reconstructs them back into electricity.
without missing a beat.
Oh, wow. And it does this
Yeah.
completely transparently. Like you don't need emulation software to trick your computer.
No, not at all. The PC just thinks the webcam or the touchscreen is plugged directly into the motherboard.
Which is incredibly rare for industrial tech, I feel like. Usually you need a network engineering background just to configure the IP addresses.
Oh, for sure. But here, it's entirely plug and play across Windows, Mac, or Linux systems.
I have to ask, though, why go to all the trouble of running physical fiber optics? I mean, we have massive enterprise-grade Wi-Fi networks now. Can you just, beam this data point to point over the air?
Well, you could try, but you'd run into the absolute ultimate enemy of data transmission, which is electromagnetic interference, or EMI.
Is EMI really that big of a deal for a regular office?
Well, see, this isn't for a standard home office. It's designed for environments swimming in massive interference. If you're using Wi-Fi or even standard heavy-duty copper cables, you are sending data via radio waves or moving electrons.
Right, of course.
And those are just so easily disrupted by other magnetic fields.
So if you run a copper cable past a giant spinning factory turbine,
The magnetic field from that turbine physically pushes the electrons in the cable around. It scrambles your data entirely.
that is wild. So that is why fiber optics are the killer feature here.
Exactly. Photons, particles of light, they don't carry an electromagnetic charge at all, so they completely ignore magnetic fields.
Wait, so you could literally wrap a fiber optic cable around an active MRI machine?
You could, yeah. And the data flowing inside wouldn't even notice.
That makes perfect sense. This isn't just about the distance, it's about surviving the chaotic environment it travels through.
Right, which also explains the physical design of the unit itself. I mean, it's a rack-mountable box measuring 17 inches wide.
And weighing a solid 8 pounds, right. Complete with an internal 100 to 240 volt power supply.
Yeah, it's built to sit in a server rack in a harsh industrial environment, not tucked behind a sleek modern desk.
And the price tag definitely reflects that industrial reality. Looking at the data from HDTVSupply, the MSRP on this unit is a staggering $4,499.
The economics of niche tech are so fascinating, though. While that is the MSRP, the listed today's price on HDTVSupply is massively discounted down to about $849.
That's a huge drop. Why the big discount?
Well, the high MSRP usually reflects the massive R&D cost for low-volume production, but vendors often slash prices to secure big enterprise contracts.
That makes sense. It's still a serious investment, but when a drop signal means a factory line halts, $850 is basically a rounding error for guaranteed stability.
Exactly. Bridging a simple physical gap sometimes requires hardcore, interference-proof engineering.
You aren't just paying for length, you're paying for armor.
It really highlights how our physical environment still dictates our technological solutions.
It really does. And I'll leave you with this final thought to ponder. In an era where we are just obsessed with everything going wireless, isn't it fascinating that the ultimate gold standard for secure, interference-free, long-distance data transmission still relies on shooting actual light through physical fiber cables?
Yeah, to get zero lag a quarter mile away, you still need a physical cord.
You really do. Thanks for joining us for this deep dive today.